Hello friends, today we will learn use of potentiometer. In the last lecture we learn about principle of potentiometer. In that the potential of that potentiometer is directly proportional to length of that wire. In that the constant proportionality is called as a potential gradient. Today we will learn the use of potentiometer. In that there are three uses in this chapter. In that first is to compare the EMF of two cells. When we can compare the two cells, at that time there are two methods. One is the individual method or a separate method, and second is the sum or difference method. First we see that separate method. In that, set up a potentiometer in such way that E is the EMF of cell, key and rheostat connected in such way that the potential at A is larger than the potential B. Those cells are compared. E1 and E2 are the compare of that EMF of cells. Positive terminal of this E1 and E2 are connected at the point A. Negative terminal of this EMF of cells E1 and E2, they are connected to the two-way key. The center terminal of that two-way key is connected to the jockey and connected to the galvanometer, and galvanometer is connected to the jockey. Here, when K close and K1 close, at that time E1 is in the circuit. And when we find out the null point on the potentiometer, that means we can find out the point on the potentiometer in such way that there is a null deflection in the galvanometer, then we can say that E1 is in the circuit, and so E1 or EMF of cell E1 is equal to potential of that potentiometer. But potential is directly proportional to potential length and the gradient constant, and so we should write here E1 is equal to K and the length for that first EMF of cell, that is EL1. Again, when K1 open and K2 close, at that time this E2 is in the circuit, and E2 is in the circuit at that time the EMF of that E2 cell is given by, according to potentiometer principle, we write here KL2. When we can divide this equation 1 and 2, that means E1 by E2 is equal to KL1 upon KL2. This KK is the potential gradient and they are cancelled, and from this E1 by E2 is equal to L1 by L2. That means we can compare the two EMF of two cells by a separate method. In that, if any one EMF of cell is known, then other EMF of can be determined by using this formula. Now we discuss about the second method to compare of EMF cells. In that, sum and difference method. If we can see that sum and difference method, in that when the positive terminal of the cell is connected to negative of the second terminal, or negative of the first terminal is connected to the positive of second cell, at that time the EMF of that cells are added and effective EMF of cells is given by E1 plus E2. That means there is a sum of that two EMF of cells. But when negative terminal of the first cell is connected to negative of the second cell, or positive of the first cell is connected to the positive of the second cell, at that time the both cells are opposed to each other, and at that time the effective EMF is given by E1 minus E2. Here in the sum and difference method, set up a potentiometer in such way that EMF of cell and K and rheostat is connected in such way that potential at A is larger than the potential B. And again, when we can connect E1, at that time here we use two-way key, but here we can use that is four-way key. In that, the there is four-way key, so this is K1 and this will K3, this is K4 and this is K2 are the terminals. In K2 and K4 the second cell is connected and K3 is connected to the galvanometer and galvanometer is connected to the jockey. When we can connect the circuit, at that time this K is closed, and in the first case K1 and K3 are closed. We can find out here the length on the potentiometer, and that length is nothing but the null point when we can see in the galvanometer. In that case, that means we can find out, that is when we can say that there is a sum or difference. If suppose K1 and K3 are closed, at that time we can see here this is the K1 and this is the K3. That means positive negative, and this is the positive negative. That means positive of terminal is connected to negative of the other and negative is connected to positive of the other. At that time there is the sum, and so we can say that effective EMF is given by E1 plus E2 is equal to that is potential gradient of that wire is K, and first length is given, that is L1. Again, when this K1 and K3 are open, and at that time this K2 and K4 are connected, at that time this negative terminal is connected to the negative and positive terminal is connected to the positive of first cell. That means their EMF of cells are opposed and there is a difference, and that difference of EMF is given by E1 minus E2 is equal to KL2. K is the potential gradient. When we can divide this equation, the equation is suppose 3 and 4. They are divided to each other. At that time, this potential gradient are the constant term, they are cancel each other. When we use componendo and dividendo method, in the componendo and dividendo method, in that numerator denominator are added, numerator denominator are subtracted in the denominator. That means when E1 plus E2 and plus E1 minus E2, and in the denominator E1 plus E2 minus E1 minus E2 is equal to L1 plus L2 upon L2 L1 minus L2. That means we should get here what we write here, E1 plus E2. This is the first term, and second term, that means we can add it E1 minus E2, and numerator denominator added and numerator denominator are subtracted, E1 plus E2 minus E1 plus E2. That means these terms are cancelled. This E2 cancel, L1 plus L2 upon L1 minus L2. That means here we write, that is twice E1 upon twice E2 is equal to L1 plus L2 upon L1 minus L2. That means we write here E1 upon E2 is equal to L1 plus L2 upon L1 minus L2. These two cancel, and from this, when two EMFs are added or sum and difference method, in that we can again compare that EMF of two cells, and in that equation we should get E1 by E2 is equal to L1 plus L2 upon L1 minus L2. Thank you.